Show that the derivative of tangent inverse of x or arctangent of x with respect to x is 1 over 1 plus x squared. To do this, we let y be tangent inverse of x. It remains to show that y prime is 1 over 1 plus x squared. And this is what we need to do. As with many cases before, every time we work with an inverse function, we need to rewrite it so that we don't have to deal with the inverse directly. Y equal tangent inverse of x means, by the definition, tangent of y equals x, assuming that we are in the first and the fourth quadrant, and we exclude negative pi over 2 and pi over 2, because tangent of an angle is not defined at the 2 points, and we need to restrict the domain so that the tangent can be 1 to 1. If it is 1 to 1, then we can talk about the inverse. Now, the goal is to get y prime from this, so we would need to differentiate the left and the right hand side with respect to x, not y, but x. And so d dx the left and d dx the right. On the left hand side, we would need to use implicit differentiation. The derivative of tangent of y is secant squared of y, but since the variable of the function is y and we take derivative with respect to x, we would need to multiply dy dx. This is implicit differentiation. The right hand side is not implicit because the derivative of x with respect to x is 1. And so dy dx equals 1 over secant squared of y, and dy dx is y prime. And that is the derivative of tangent inverse of x. But we cannot leave the answer in terms of y, because y is tangent inverse of x. In fact, it is defined explicitly. There's no y on the right hand side here, and so we would need to find a way to rewrite y in terms of x. And to do that, we can either use the trig identities, or we can use the fact that tangent of y equals x, which is x over 1, and tangent is the opposite over the adjacent in a right triangle. In this right triangle, y is the angle. Since tangent is x over 1, we let the opposite be x and the adjacent be 1. The missing side is therefore the hypotenuse, and the hypotenuse, using the Pythagorean identity or theorem, it is 1 squared plus x squared, the square root. Now, y prime is 1 over secant squared of y, or cosine squared of y. 1 over secant is cosine. Cosine is the reciprocal of secant, and vice versa. Now, using this right triangle, cosine of y is adjacent over hypotenuse, and so cosine squared of y is cosine of y, the quantity squared, but cosine of y is 1 over the square root of 1 plus x squared. Therefore, y prime is 1 over 1 plus x squared. We just show that the derivative of tangent inverse of x is 1 over 1 plus x squared.